Welcome to this webinar by the IQME Safety Centre. My name is Trish Kerin and I'm the Director of the IQME Safety Centre. In this webinar we are going to discuss human factors and safety culture. I'm going to be using the story of cave diving as a way to explain these concepts. Firstly, let's talk about human factors. Human factors is about that intersection between the individual, the organisation and the task. Human factors is important to make sure we can actually get things right rather than get things wrong. So I like to summarise it as making it as easy as possible for the human to get it right, then as easy as possible for the human to get it wrong. So if we can focus on how we can just intuitively stumble into the right way, that to me is good human factors. If we consider one of the early examples of human factors in the modern world, that's actually looking at the automated teller machine. So for example, when they were created, we would go to the bank, we'd put our card in, we'd put our PIN in, and we'd get our money out. And the problem with that process, whilst it sounds very logical, was that as a human, we had an objective to achieve, getting the money out. Once we got that objective, our brain had moved on and we'd gone on to thinking about something else, and we were forgetting our cards. So what was changed was just the simple logic sequence of how ATMs worked. Now we put our card in, we put our PIN in, we get our card back, we get our money. Or indeed there are other examples where there are a swipe or an insert and withdraw the card. This is all designed to make it as easy as possible for us to get it right, rather than as easy for us to get it wrong. The Health and Safety Executive in the UK defined 10 specific aspects of human factors. And these are managing human failures, procedures, training and competence, staffing, organisational change, safety critical communications, human factors in design, fatigue and shift work, organisational culture, and maintenance, inspection and testing. And all of these areas are very critical to our day-to-day operations, even more so as the world is facing a pandemic at this time. I'll also want to talk about culture, and there's quite a long definition here on the screen from Edgar Schein, who's done an enormous amount of work in understanding culture in organisations. And really, there's some key aspects in this. Things like it's the accumulated learning is a pattern or system of beliefs and values, behaviours, norms that come to be taken for granted. They're the basic assumptions. Some people often summarise this as the way we do things around here. Now, the way we do things around here is a really useful, practical application of what culture actually looks like in an organisation. But I think there's a step further. It's actually the way we do things around here at 3 a.m. What I mean by that is when no one's watching us. How we behave and conduct ourselves when people are around and people are observing what we're doing is one thing. How we behave and conduct ourselves when we're working alone or doing something where others can't see us, that truly defines the organisational culture. How we do things when no one's watching really says a lot about how we actually do things. Okay, so now let's talk about cave diving. So cave diving is often said to be a particularly hazardous sport. And when people found out that I used to be a cave diver, or even when I was cave diving, they would always say, "Why do you do it? That just seems crazy." And really, for me personally, it was actually about doing it because I could. Not everybody can. There are physical requirements to it and there are emotional, mental requirements to it. And without those, you actually can't successfully cave dive. It also led me to one of my greatest achievements ever, which was getting to a point in a remote cave in Western Australia called the Rock Pile in Cocklebiddy Cave. And this was very special to me, this moment, because actually that slate that's in that photo, there was less than 100 names on that slate when I added my name to it. So not many people had ever been to the Rock Pile back when I went there. So, you know, the sense of achievement. But with all of that, we have to understand that there are hazards. And there's significant hazards in a cave. You're in an overhead environment. You're on a life support system because you're underwater. There are many things that can go wrong, and dealing with those hazards. This overhead environment means you can't just come straight to the surface to get out. You actually have to solve problems because the surface for you in a cave is actually not the answer to your problem. And there are consequences. When we talk about cave diving, we know that these consequences are actually potential fatality consequences. It's very much drummed into you when you learn to cave dive that there's no such thing as search and rescue. There's only potential body recovery. So we understand how serious these consequences are when we go into a cave. And therefore, we apply some very stringent risk management processes. And I'm going to take you through the different processes that we apply and talk about how human factors and even culture impact those particular things that we have to do. Okay, so the core requirements. There are a number of different core requirements in cave diving. Firstly, there's skill. Fundamentally, you have to actually be able to dive with quite a high degree of skill and buoyancy control. You have to have the right attitude. And this is actually something quite different for people to grasp, because we don't often talk about people's attitudes towards safety or towards risk or towards the hazards that they're dealing with or work in general. But it actually can have quite a significant impact, and that's different to behaviour. There's also planning requirements and equipment requirements that you need to be dealing with. I'm going to go through each of these 4 areas separately. So if we talk about skill, first of all, a little bit of history. Back in the early days of cave diving in Australia, there were a number of very tragic fatalities over a very short period of time. And that led the government to start to think about needing to regulate cave diving. And there was concern amongst the scuba divers at the time that that might mean cave diving would be outlawed. So they banded together to try and implement some sort of self-regulation to make their sport safer. And so after, I think it was 11 odd fatalities over a very short period of time, a couple of years, after they introduced significant competency and training requirements and a requirement to be part of an association that provided then access to the cave sites, they didn't have another fatality for over 35 years. So that was from quite a high fatality rate to nothing for many, many, many years. So that training and competence element that they introduced was so significant in what they were doing there. And that training part was it's quite a challenging training course to go through. Part of it is, or most of it in fact, is done underwater without a mask on and blindfolded. This is testing not only your physical capabilities but also your psychological capabilities in terms of remaining calm when things go wrong. And the instructors will remove the regulator from your mouth. You can't see it happening, so you just have to respond to what's going on and remain calm. So the testing that they do is quite stringent, and even in fact at the highest levels of cave diving, the most difficult caves, you can actually be failed in the training program for your attitude. If you don't have the right attitude towards cave diving, you won't be allowed to go cave diving. And so this actually introduces the skill part, a number of these human factors areas, and part of that culture as well, that as an association everybody abided by the standards and the requirements and the values that were necessary so that we could all continue to do this sport as safely as possible. So managing of human failures is particularly important. The training is all about how you respond when things go wrong. When you make a mistake, how do you recover? What do you then do? You're also trained extensively in the procedures. So what procedures do you have in your workplace? Do people actually understand them? Can they follow them? And are they going to deliver the right outcomes for you? Training and competence. What training and competence programs do you have in your organisation? And how are they then rolled out to make sure that people are not only trained, but then assessed as being competent? Because merely doing a training course does not make you competent. You actually still have other aspects of learning to practice those skills. And the staffing. Do you have the right people around to make the right decisions at the right times? These are all critical human factors elements. If we move on to attitude, and as I said, this one's a little bit different because talking about attitude is something that we often don't really do in the workplace, but it is vitally important. This is all about teamwork, how the organisation comes together, how you manage things like fatigue, how you maintain the positive culture so that everybody is on the same page going forward with what they need to be doing. And an example here is, whilst it sounds quite flippant, and it used to be almost said as a little bit of a joke, if you weren't comfortable going on a particular cave dive for some reason, all you had to say to your buddy was, "Today's not a good day to die." And that was the message that we used amongst ourselves to say, "I'm not doing this dive." And if it was just you and your buddy, then your buddy would say, "Okay, let's go and get a coffee. we won't do the dive. Rather than, oh, it's okay, it's just a quick dive, you can do it. That doesn't happen in this particular area. The culture and the attitude of people diving in this space is really quite fascinating to observe, because it is not the sort of thing we see often in the workplace. Now, obviously, depending on what your workplace is, you can't actually decide not to do something today because today's not a good day to dive. It doesn't work like that. But you need to be managing things like simultaneous operations. If, for example, you're in the middle of doing maintenance on your fire pump system or your fire protection system, you don't go and do hot work at the same time. So that is the equivalent of today's not a good day to die. Looking at what's happening and managing the risk and reducing or eliminating it where you can. So this is even still something that is applicable to what we need to do every day at work. And this is similar to the stop work authority that we talk about, when we can say, hey, we don't think it's the right thing to do this right now. We actually think we need to stop what we're doing, change what we're doing, or modify it in some way. So in terms of the human factors elements here, again, it is around these managing of human failures. How do we deal with an error when it's made? How is the team functioning in terms of if someone makes an error? How do people respond and help the person that's made the error to learn and to move forward and understand and progress? Managing of shift work and fatigue is critically important in attitude as well. We can't just assume that people can just keep turning up. We actually need to be actively managing it, especially as we go through potential instances at the moment where we're going to see reduced availability of labour to do what needs to be done because of illness. So this is a really significant area to think about at the moment. And your culture. What is your cultural message out there? If someone does actually decide that they think they need to stop something because it's not safe, what response does management give to that person when they stand up and say, hey, we need to stop this? If that response is, no, just get on and do it, or even as simple as just rolling your eyes going, oh, again, that sends a very clear message to the person, and they probably won't stand up and say something again. So what you need to be doing is saying, okay, we need to understand what the issue is. Thank you for bringing it to our attention. We'll now work on fixing this together. But remember, that actually has to be a genuine commitment too, not just lip service. Okay, in planning, there's a couple of different aspects in planning we're going to go through. So there's the site, air, duration, depth, and the distance. So when we start to talk about the site, we actually need to understand the access to the site. So as an example, this is quite a scary photo when you look at it, particularly from a safety perspective, of me climbing down a wire ladder with a set of tanks on my back. How easy is it to get in and out of your facility or a particular part of your facility? Do you have clear access for people, not only in the role of doing their job, but also in the event of managing an emergency? What does your risk assessment say about site access to different parts of your facility and how you're managing that? How does your emergency response process work? In these particular sites of the photos that you're seeing right now, our emergency response protocols, because we were in the middle of nowhere with no cellular service, was that we actually had to phone back to civilization effectively every morning and say, okay, we're going to do this cave site. We will be here from this time to this time. We will phone you again when we get back to our campsite. We anticipate that to be in 12 hours' time. If we didn't respond back in 12 hours' time, then they knew that they needed to send someone out to look for us. So sometimes your emergency response systems are quite unique, but you do need to make sure that even in something like recreational diving or cave diving, you still have those processes in place. Now, when you're looking at a site to go and dive, you're actually going to look at the objective. You're going to want to know what you want to do in that cave site. So, for example, here is a map of a cave site called the Pines. It's located in South Australia. Now, you can see here that there is actually a couple of different parts of it. We've got the main chimney that comes down here, but we've also got a site that you would access through this way. So if you're going to go down into the big room down in here, then you need to decide that up front as part of your cave planning, because you can't physically get there if you go down the main chimney. So that's why we actually need to make sure we clearly state what our objective is. Where are we trying to go on this dive? So how do we manage those human failures? If someone had fallen in using these ladders, how do we deal with those emergency response issues? How are you managing access to your site and parts of your site that maybe we don't go to all the time, but when we do, there are special access requirements? How have they been risk assessed? And how would you respond to rescuing someone, for example, if they were injured on a high platform? How do you deal with your procedures? Are they clearly defined? Does everybody understand where they can go on the site, the access requirements and what they need to be doing, and in fact what their objective is for going to certain parts of the plant? There will be parts of our facilities where you need a very specific objective to be going to. Do you have the right number of people to respond from a staffing perspective to an emergency or an issue that arises? And how do you deal with organisational change? So at the moment, if you need a certain number of people to manage your facility from a safety perspective, how are you dealing with the risk assessment and potential organisational change if some of those key personnel are not available due to illness at this particular point in time? We need to be very carefully managing those organisational changes. Thinking about air and the planning of air. So there are certain procedures and limits that we have to follow in cave diving. If you're in a sinkhole area, you can use 1/3 of your air before you need to terminate your dive and turn around and come back out. If you're in a cave and overhead system, it's 1/4 of your air. If you're in a cave and you're on a motorised scooter, it's down to 1/10 of your air. And this is because we actually assume that we'll have a failure of your air system at the worst possible point. Now you'll notice there in the photo that there is actually some manifolded tanks together. So if I lost control of one of my tanks through bursting of an O-ring, for example, and was losing air, I could isolate the other tank so that I only lost the contents of one tank, the one that had the O-ring failure. So that's why we do have these very prescriptive limits on how long or how much air you can use before it's time to turn around and come back out again. In terms of emergency response, do you have access to potentially your buddy's air if you need it? And that's when you have certain setups and things. So for example, your main regulator is actually on 2 meters of hose length. That is so that it's long enough for you to actually have to share it if you need to, whilst your backup regulator is only on about 40 centimeters of hose length. It literally just sits at the base of your chin waiting for it to be needed. And that comes into the redundancy. So you've got your redundant regulators. They come off separate tanks. You can isolate those tanks. You then have your redundant tanks. You can isolate your tanks in between as well. There's a whole lot of other equipment that you have that you carry redundancy in as well, but from the air perspective, they're the main redundant aspects you have. Depending on the diving, you might also have separate tanks as well. So thinking about your organisations, what procedures do you have in place that limit what you can do? And these are things that define, for example, your operating windows. How are you managing your operating windows in your facility? How are you then managing your alarm states and levels, and as you then keep moving out to relief systems, potentially shutdown systems? How are they defined, and does everybody understand them? How are emergency situations communicated? Safety critical communications are so important. We often neglect them, but sometimes we can have a little bit of misunderstanding on describing a particular piece of equipment between one group to the next, and most of the time that's okay, it doesn't matter. But in an emergency situation, that communication is absolutely critical. In cave diving, we actually learn to communicate, at the very worst, using one hand only and tactile signals. So a certain number of hand squeezes mean a certain response or a certain issue, because we have to assume that we actually won't have any visibility. If everything has really gone wrong, we may not have any visibility. We need to be able to communicate using our hand tactilely to our buddy, and potentially only using one hand, so you can't use two. We have to learn a whole new series of signals. Even when we do have visibility, we have a whole new series of dive signals that use one hand to communicate only. Things like the ability to count to 10 on one hand without using the second hand for the last 5 fingers. These sorts of things are part of safety critical communications. And lastly, you need the right maintenance, inspection and testing regimes. You need to make sure that your equipment is going to be working. So in the case of cave diving, every dive, the O-rings were checked to make sure that they were still looking in good condition prior to the dive. Other things such as O-rings on torches were checked and greased before every dive. Equipment is tested. It is maintained. This is your life support system. You have similar sorts of equipment in your own facilities. Your fire systems. You might even have self-contained breathing apparatus for emergency response. How is all of that equipment tested and maintained? As well as your safety critical shutdown systems. You need to know they're going to work if you have to call on them. The duration of a dive. There's many factors that come into how long a dive can actually go for. So the depth you're going to, how much air you actually breathe or breathing gas, how much you actually consume in an average dive, what the water temperature is, because that will change how much air you consume. If you're diving in warm water, you'll typically breathe less than if you're diving in quite cold water. And the maximum planned duration will also have a factor here. So you're actually going to look at all the other factors and decide how long your dive can be, and then you'll have a maximum duration that you're allowed to have. And then we do what's called a runtime. So you'll actually plan your complete runtime. So it might be, for example, 10 minutes to get to the depth that you're going to, 10 minutes down there to explore, and then 30 minutes to do your ascent, including any necessary decompression. And you will manage each part of that runtime. You will need to make sure. So if you happen to get to your dive site early, say you get to your depth that you want to get to in 8 minutes instead of 10 minutes, that actually doesn't mean you get 12 minutes at the depth, because that changes your decompression requirements. You still only have 10 meters at that depth. So sometimes we do need to adjust things on the run, but we do try and stick as much as possible to our planned run times. These are our procedures. These are actually how we define what needs to be done and when and how. And so that is why procedures are so critical. It's also important to take into account the staffing. You know, who have you got around you and what are they doing to achieve the overall objective of what's going on? How long are they going to be there for, and what is their role? Organisational change. What happens if we do get to our depth in 8 minutes? As I said, that means we actually need to adjust our overall end time to the dive, but we don't get to adjust the extra time we spend at depth, for example. So managing organisational change also needs to be done. The depth requirements for planning. Again, there are multiple factors that come into play here. What breathing gas you're actually using. You could be using standard air at 79% nitrogen, 21% oxygen approximately, or you might be using 32% oxygen or 36% oxygen, or you could even be using a trimix with a blend of helium, oxygen and nitrogen, for example. The reason that you might change your breathing gas is because of the depth you're going to, or because of the duration you want to spend down there. One of the challenges, though, that we have is often in scuba diving, we will use a higher oxygen content air because it can minimise the impact of nitrogen narcosis, which is a very significant impact that can have on your body. It's transitory, so once you get to a depth, you might actually find that you can't concentrate quite as well, you're just a little bit muddled, you're not quite sure. You might not even necessarily feel it, but you might be behaving in an unusual way. It is a narcosis effect that occurs. Coming back up a couple of meters to a shallower depth, your mind will clear, the narcosis will disappear. But the challenge with using more oxygen in your breathing air is you can't go as deep because you also have to manage the risk of oxygen toxicity, which can be quite substantially an issue at depth. So you need to understand all of these different factors. How long are you going to spend at depth will also have an impact on the depth that you can go to. The deeper you're going, the shorter your time down there. And the site layout itself. Unfortunately, sometimes in caves, you might actually have to spend the first part of the dive at a shallow depth to get to the deep part. This can happen occasionally, and it's what we call a reverse profile in diving, and we usually try and avoid those. But sometimes in caves, we may have to manage them a little bit differently. So in terms of managing those human failures, this is the narcosis part. So, we have drug and alcohol requirements and testing in our workplaces to reduce artificial narcosis that we may suffer from external substances. But other issues that could occur, for example, in the workplace. If someone is particularly stressed about something that's happening in their life outside of work, or even concern about something that's going on in the company if there's uncertainty. This could have some quite significant impacts to a person in terms of distraction, and that distraction could result in them making a mistake, and that could be a problem in itself. So we need to be looking out for each other, and if someone doesn't look quite right, they're not quite concentrating, hey, are you okay? Is there something I can help you with? And I think that's even more important now as we go through the uncertainty that we're currently seeing with this pandemic, because people will be stressed. They might have family members that are ill. They will have all sorts of different things going on in their lives. We need to be looking out for each other and taking care so that we can try and minimise the human failures that might occur due to distraction, but also respond as quickly as possible when they do occur with empathy, compassion and understanding. Procedures. We need to define these things very clearly. So there are very strict rules around what breathing gases you can breathe at certain depths and for how long. They're there for a reason. These are your critical operating procedures, for example. They're there for a reason. You have to follow them because they're actually there to keep you alive. And making sure you've got the competence to use the air that you're using to do the things that you're doing. These are also very important aspects because you need to understand, for example, how all the requirements come together for using something such as a 36% oxygen nitrox blend. It's different to breathing air. You need to be trained in it. Direction. This may sound silly, but you do need to think about the direction you're going to travel in a cave. There are very few caves that have a different entrance and exit. You usually go in one area and you come out the precise same way. You will go and you will lay a line as you go in so that you have a continual line to the surface, because that is actually how you will get out in the case of an emergency. The order of your divers is also important. You will remain in a particular order. The first person in will be the first person potentially that's laying the line in there if it's not a permanent line. The next person then may have a particular task that they do. They might have to actually check that the line is secure for the person laying it. When it comes time at the end of the dive to come back out, the first person in is the last person out. You actually maintain your position on the line, turn around 180 degrees and progress out in the way you came in. And that way everybody is clear in understanding what their role is. They know their task. They need to be skilled in other tasks because they may need to do something different. They may need to take on an extra job because of an injury or an issue that arises. But everybody has to have a specific task. We also have this continuous line with line markers, and that's a photo of a line marker. The line marker, the arrow, always points out of the cave. It always points to the exit. So this is another human factors thing. You can follow the direction of the arrow. If you lose visibility, you can feel your way along the line, feel the arrow and follow your direction out. So it's always really important to use line markers so that you can find your way back out when you need to. So these are all things about managing human failures and procedures. You need to be trained in the task that you have to do. You will have specific operators that will come on shift potentially, and they will operate a particular part of the facility. They need to be competent in that particular part of the facility. They need to understand the procedures. You need to make sure you've got the adequate staffing. But if something happens and you need to make an organisational change to help them, how do you go through that process to make sure that you can make that change? And how do you deal with the safety critical communications to make sure everybody knows what's going on? And importantly as well, the human factors in design. So the line marker is an example of it. Intuitively, we follow the arrow of the direction of the arrow is pointing. But think about other factors of design. Is the equipment intuitive in terms of how you are going to use it? So for example, I've seen examples of design where there might be multiple reactors in a row, each with different buttons, and the buttons are all in the same order for 3 of the reactors, but the 4th reactor, the buttons are reversed. That will lead to a human making an error because the system is set up in such a way to make it easy for them to get it wrong. So how are we dealing with our human factors in design in our facilities? And sometimes it might just be simple changes that need to be made, not significant engineering changes. The equipment. There's a lot of equipment required in cave diving, an enormous amount. About 130 pound or 60 kilos of equipment to do any particular dive. You can see in the top photo there that it looks like a bit of a mess. I've got stuff everywhere, but actually that was a pretty neat setup for the situation we were in. there wasn't even room to clearly stand up. So you had to actually figure out how to get all your gear on, all your gear together in its right configuration to go diving. You also had to have the right amount of redundancy. Now, this is important in terms of how you configure your equipment and how much of everything you have. So I've talked previously, there were 2 tanks. They were manifolded. That was my configuration. But I could reach that manifold with one hand to isolate if I needed to. I could reach a line cutting device if I became trapped in some way to be able to cut myself free. All of these things I could do with one single hand. Everything was set up in such a way that my configuration was to minimize any line traps or hazards that could eventuate, and make sure I could manage what was going on in my own equipment and be able to reach it. But you've got to make sure it's necessary while not being excessive. Now, sometimes people would suggest that perhaps I had an excessive number of torches on me when I cave dived. And I used to actually carry 9 individual torches, which does sound like a lot, but there were 2 mounted on my helmet, and then there was my main torch. So straight away, that's 3 torches. And then I had a backup torch. Well, that's 4 torches. The other 5, some of them were, as small as a small pen light tucked away somewhere. Because if you have a failure of your O-ring on your torch and you prepared all of the O-rings on all of your torches, are you the common mode failure? Just when one thing fails, you need to be prepared that the second piece of equipment, the redundant piece, might fail as well. And this is something that I don't think we necessarily always do really well in industry. We might have a redundant pump setup, and when one pump fails, we switch over to the other. But how quickly do we assess our risk situation then? Because at that point in time, we no longer have redundant equipment until that first pump is serviced and brought back into service again. So we need to think about when things change. If we have redundant setups and one thing fails, we need to actually assess the risk at that point of what we do going forward. Now, the answer is not necessarily to have 3 pieces of equipment instead of 2. There are issues that can actually increase the risk by just adding more equipment. Adding more bells and whistles is not the answer. But we need to make sure we assess the risk and we have the right training process and maintenance programs in place for people to follow so that we can manage that. So having the redundancy of equipment and having the right configuration is all around trying to manage these human failures. How easy is it to get to some of the equipment in your facility that you need to get to, particularly in an emergency situation? This is when it becomes very, very important. Again, the human factors of how easy is it to use some of the equipment you have in those situations. And you need to make sure, as I said, that all of your safety critical equipment has a very thorough maintenance inspection and testing regime. If you need to call on your emergency equipment, you want to know that it's going to work, because at the time you're calling on it, it's an emergency. It may well be your last chance at something. So you want to make sure it's good. So that's what I wanted to talk about in terms of cave diving and human factors elements and also the cultural elements. There's an enormous amount of discipline that goes in cave diving, and that discipline actually is a cultural element. Everybody that goes into cave diving did have the same level of discipline. There were some instances where people I had dived with I didn't want to dive with again, and there were other people that I would have always gone into a cave with because I trusted their capability and their experience. One of the things I did learn, interestingly, as we went through the process of learning to cave dive and developing, and I had the fortune of diving with some very experienced cave diving instructors as well. As you go through the process of learning to cave dive, you learn to be able to spot the people that think their skills are better than they actually are. And they're the people you try and avoid. But people that actually think they're not quite as experienced or capable as they actually are, they're the people you want to dive with, because they have a sense of vulnerability. They have a sense of fear. There's always a healthy level of fear needed to do anything that is high risk. If you don't have a healthy level of fear, and I'm not talking about a paralyzing level of fear, but a healthy respect for what's going on, then chances are you will end up in a situation where something significant goes wrong. And that's not a situation you want to be in. The photos I've just shown up here is obviously, there are some warning signs. There are always warning signs. Be extremely cautious in the caves. Well, I think you need to be more than extremely cautious. You actually need to manage the risk. You need to have the right focus on human factors in what you're doing, and you need to have the right culture going forward with your diving team to make sure that you can survive if something goes wrong. And we need to be doing that at work too. We have to have the right people trained. We have to have the right equipment. We have to be willing to respond. We have to work together. We have to have the culture of working together and helping each other to solve the problem. These are really critically important things, particularly at the moment. And the sign. So Eucla was a town that we were camping in. The caves themselves were still, an hour or so drive out of Eucla into the desert. And you can see there that Eucla is actually pretty much in the middle of nowhere. There's not a lot around other than a big fuel stop. And that's pretty much it. You are kilometres or miles from anywhere at this point in time. So you need to make sure that you really have good systems and processes in place. You're focusing on making sure that you've got the right equipment, that you're competent. You've done your assurance to understand that all your equipment works. You've got your human factors sorted out so your cave kit can be operated one-handed in the dark without any visibility at all. You've got the right culture happening there, and you've got the processes and procedures to follow. These are the really, really important things, and they all translate directly into the work we do every day in major hazard facilities all over the world. I hope you enjoyed this webinar. It's just a brief introduction to some of the concepts and potentially how some of these ideas or concepts could actually apply in your organisation as you go through with operating your facilities and trying to maintain safety. Thank you for your attention. Please feel free to follow us on social media. We are very active on getting different little short videos, updates, and we're doing a lot more work now with webinars. We have a YouTube channel, so you can actually check out all of our past webinars and keep an eye on it because we'll be continuing to upload ones into the future. Thank you so much for your attention. Please stay safe and take care in this time.